So our first video on standard deviation, we just introduced it here with a couple of easy sets. It's the average spread from the mean of all the values in the set, standard deviation. We're going to use our calculators in most cases just to calculate this, but we will look in this video at a manual way to do it. If your calculator runs out of battery, God forbid, in the middle of an exam, it is a reliable measure of spread. However, if extreme values are in the set, it's going to throw them out. This standard deviation won't really be reflective of everything. And in set A and set B here, there's two sets, and if we take mu to be the average or the mean of a population, we're going to see this when we start doing some Z scores. The mean of a population, the mean of set A. If we add them all together, we're going to get 14, 11, 25 and 25, which is 50. So the mean of set A is B, or is 10, sorry, and of B it also adds up to 50, so the mean of set B is also 10. So how do we get standard deviation? So standard deviation is a formula where we take what we're testing, which we'll call x, which are all my values in my set. What we have to do with x is we have to put the average of the set beside it. We have to find the difference between the average and x, and we have to find the difference squared. So let's do that for set A here. And we'll see what we do then when we have all our different squareds. So my value is 8, 8, 9, 11, 14. 8, 8, 9, 11, and 14. So the difference between my value, my set value, and the average, which is 10, will give me D, which is my difference. Now, I'm just going to put them in as positive. The difference here, you could put in as negative too, but we're going to square it anyway. So the difference doesn't matter whether it's negative or positive, but I'm just going to put them in as positive. So we're going to get the difference squared to be 4, 4, 1, 1, and 16. And what I want to do, you're going to see this. This is the sum of D squared is equal to 16 and 4 is 20 and 6 is 26. And if I apply this to my standard deviation formula, which is this sigma, it's equal to the square root of the sum of the difference squared divided by the numbers in the set, which we'll call n. So what we have here for sigma is the square root of 26 over 5, which is the square root of 5.2, which is 2.28. So my average spread for each value in set A away from the average is 2.28 by standard deviation. Now, a set with the same mean can have a different standard deviation. So if I fill set B in here, I know that the average is 10. My values are going to change here. Maybe quicker just doing a new one, but it's there. Just apply all these values all the way down and see what we get. We're still going to get 5. And we'll see what our standard deviation becomes. So I have a 1, a 5, a 9, a 14, and a 21. My difference is 9, 5, 1, 4, and 11. And my difference squared 81, 25, 1, 16, and 121. And I'll add all those together. I'm going to get 244. So 244 divided by 5, and the square root of 244 over 5, that's 48, so 6.99. 6.99 is my standard deviation for set B. Different than the 2.28 we got for set A, even though they have the same mean. So what does this tell us about the values in the sets? Well, you can see here, they're more closely aligned, set A, they're much closer together, whereas there's a bigger spread in set B. The range here is 20, 21 minus 1, and the range here is just 6. Smaller range, smaller standard deviation. Now, practice these two sets of data on your calculator for standard deviation, and you'll know really quickly with only 5 sets of data whether you're correct or not. In the exam, there could be up to maybe 12, 14, 16 pieces of data. So just perfect using your calculator for standard deviation. This video, just an introduction to it. Classroom practice now for standard deviation on a calc.